All right, the next thing we're going to look at is the reactions of alkenes, and these are all called addition reactions because you add the two reactants together and form only one product. So on the left here, I've got but2-ene and I'm reacting it with bromine. And in order to add these two molecules together, I'm going to have to lose something. And you'll see that what I've lost is the double bond. Now that the double bond is broken, we should hopefully be able to see where I'm going to add my bromines. The two carbons here that were previously part of the double bond now only have 3 bonds each. So they each have space to pick up a bromine. So I'm putting a bromine on each of those carbons. But just double check that the carbons that were part of your double bond are now the carbons that have the bromines. You shouldn't have 2 bromines on the same carbon, nor should you have a bromine here on carbon number 1 when carbon number 1 did not start with a double bond. So 2 bromine atoms being added, 1 to each carbon of the double bond. And during this reaction, you're going to see a color change. So we call this reagent bromine water. It's just bromine dissolved in water, so Br2 aqueous, and this has an orange color. And when you do this reaction, because the bromine gets used up and becomes this new product here, it goes from orange to colorless. And we say that this is the test for unsaturation. If the double bond wasn't there, if it wasn't unsaturated, you wouldn't see this color change. So this color change tells you that your starting molecule is definitely unsaturated. We call it the test for unsaturation. But this will work with any of your other halogens, all right? So you could add Cl2, you could add I2. It will work with any of your halogens. It's just typically we do it with bromine. The other reaction that you need to know with the alkenes is again another addition reaction, but this time instead of adding a halogen, we're adding water, and we do it as steam. So H2O was a gas. We're using quite high temperatures here. And again, what's going to happen is because we're adding these together, something's got to go, and it's the double bond that goes. So again, you'll see that I've drawn my product without that double bond, and hopefully now we'll see that there's space to add in extra groups. Now the H2O will split into a H and an OH. So one of these carbons is going to pick up, I should put an OH there already. One of these carbons is going to pick up an OH, the other will pick up a H. Doesn't matter which way you do it, let's put the H on the first carbon and the OH on the second carbon. So I've hydrated my alkene, I've added water, so I've hydrated it, and I've gone from an alkene, ethene, to the alcohol, ethanol. So if you hydrate an alkene, you will form an alcohol. And this reaction is particularly useful because ethanol is the alcohol we have in our alcoholic drinks. The other way you can form ethanol is through fermentation, but this is also a method used to form ethanol. The advantage of this is that you've got a 100% atom economy. Nothing is wasted because you're only forming one product.